My name is Frederich Tschuschke, and I'm very pleased to tell you a little bit more about the topic of battery safety. It's an important topic, I guess. So, a short introduction from my side. Yes, I'm 33 years old. I'm the product manager of SVT products in the area of passive fire protection and battery safety. I prepare a small presentation for you to give you an insight what we're doing in the area of passive fire protection for battery safeties, and also give you a short introduction. So the agenda for today is, as I already told you, a short introduction of SVT products, who we are, what we are doing, the risk of batteries, the products and solutions that we have at SVT products, and our R&D and testing solutions for this kind of topic. Who we are? SVT is the market leader in Germany since 1969 in the area of passive fire protection. So we had an anniversary of 50 years last year. Normally we came from the construction side for fire protection, but we also have business units in the industrial sector. I will show you later on. Just a small overview, just a few facts and figures. So founding year, as I told you, was 1969. Staff size are already over 800. Turnover is about 180 million a year. We have locations, over 30 locations in Germany and 4 production sites. The scope of activities, as I already told you, we are the passive structural fire protection in construction area, but we also have fire protection for industrial application like I do, and the area of damage restoration. So now here are the partners from us, and yeah, our headquarters is in Hamburg, Germany. Also, as I told you, our 4 production sites are all in Germany. We got a partner in SVT in Poland, also in Turkey, Russia. We got a office in the Middle East and Asia Pacific, and we have over 50 representatives in all over the world. Here are our market segments in the industrial sector. So as I told you, we have the construction area, the energy, rolling stock and aviation. That's my part as the battery safety part. So I'm the product manager of these 3 topics. But we have also the ships and offshore, renewable energies, and special requirements. So we got a whole bunch of business units for the industrial sector. Should I start with the topic of battery safety? So here's a small overview what we are doing and in which kind of topics we are have some products and some solutions for the area of battery safety. As you can see below, we focus here on the production, on the transport, and the storage of the batteries. But the most important thing is the e-mobility, so the field of using maybe in a car, electric car. And also the recycling of the damaged batteries is also an important topic, because you have to bring the battery from the case of fire to the recycling. The products that we use, we have some different kind of products. So we have the coatings, we have some molded parts, some PU-based materials, a lot of fabrics, fire stop boards, composite material, filler sealings, and some special solutions. But later on I will tell you a little bit more about our product and solutions. Right now I want to start with the risk of batteries. So as you can see the pictures, everyone knows the risk of batteries. So there are the Tesla, that's the most famous picture, I guess. But you can see some battery cells that reacts, and you have the most risks is a cell failure. You got thermal runaway. When you got the thermal runaway, you get the propagation of the cells. And this is happening because of a cell failure, overloading or overheating from the battery system. Yeah, the formation products in thermal runaway. What happens when a thermal runaway in the battery cell is happening? So we got all kinds of happenings. We got the gas and the pressure, we got the heat, we got the particles, and we got the acids. Our products can be successful in 3 types from these 4. We can use the gas and pressure, we can the heat, the particles, but what we can't, but what we can do is the acid. We can fight the acid. So we basically use these 3 kinds of formation products to protect with our materials. Here are the range of the material possibilities that SVT products have in this kind of area. So we got a whole range of possibilities. We got a really great product portfolio that we can use to protect batteries or to protect everything around the battery. So we got some reactive materials, we got insulating materials, we got seals and granulates, we have some coatings, and also fire protection panels. I show you later on what you can use in which kind of situation. So for you, I don't know if you really know what passive fire protection really is and what kind of material we use. So a lot of our materials are intumescent materials. Intumescent is the material starts to react at a temperature of approximately 150 degrees and build an insulating layer of carbon foam. As you can see below, there are the small the reaction temperature starts, and the material builds a foam that insulates the substrate. Now I'm starting with the products that we use. For example, this one is a coating that can be used in many different ways. It's a PU-based coating that's developed for the rolling stock area, but also can use in the battery safety area, because it has a large protection of variety of chemicals and mechanical impact. So it can use for storage or transport, or it can use for battery cells, or it can use for the battery system. It depends on the requirements on the system, but you can use it. You got a high climatic resistance from this material. It's water resistant and has already some sound reducing properties that you can use. But in the case of the battery, you don't have this much sounds, so you don't need this very much. You also have short drying times and process times. That's of course really important for the big customers, the big OEMs, for example, the automotive guys. So this product here is, as I told you before, we got some intumescent coatings or intumescent materials, but we also have some cooling materials. This coating is a cooling material, so it's ablative, it's endothermic. You can use it to cool down the substrate. It reacts at a temperature approximately 200 degrees and have bonded water inside, and release this bonded water and cool down the system or cool down the construction. So it's one of our oldest materials. It's over 20 years now in charge, and yeah, it's really good for cooling down the substrates. Now we go to the topic of fabrics. We also have a lot of fabrics that we can use for different kind of requirements. So I tell you this all very generally, because there are so many different kind of requirements that we have for the battery cell inside, or for the system, or for the storage, or for the transport, that we don't have this one solution. We can use everything. So maybe we can use a fabric for cooling down, or for prevent the whole construction, like a cabinet, for example. You can put it inside, and if the cells react, you can cool down the construction, and you can the intumescent foam builds an insulating layer. Also, you can combine these two materials. So as you can see here on the picture, you got the blue one, that's the cooling material, and you got the red one. The red one is the intumescent material. If you combine these two together, you can see in the table, you can get so much energy from the fire and cool down the whole structure. You got a minimal thickness of 1.7 millimeters, or a maximum thickness of 4.5 millimeters. And as you can see, you can achieve up to EA90 in a construction, but you don't really need 90 minutes in the case of fire, in the battery fire. And you have 3 times more bonded water than a comparable plasterboard. So you're thinner and you are lighter. And the construction, the lightweight, is the main focus from us. Here are some other products that we can use. For example, that's a PU-based foam, or a PU-based casting system. The casting system you can use, for example, for cable management, and the foam. We got some projects right now where we have this foam and we cut it by water jet. We have a water jet inside, a water jet cutting machine in one of our production sites, and we can cut these kind of materials perfectly in form of the cells. So you can cover the cells with this foam, for example, and if you got a thermal runaway, the foam is also intumescent materials, is between the cells, and stops the propagation of one cell to another cell. As I told you before, we call it the special solutions. So we got some fire protection granulate, and with this granulate, it's possible to produce 3D printed components with fire protection requirements, and some injection molded parts, as you can see on the picture below on the left side. So this granulate is 100% intumescent material. So if you got the special construction, the special form of your component that have to be fire retardant or have fire protection requirements, you can use this granulate for injection molding, or even print your own 3D part. Also, we have some ceilings. It's could be important and could be interesting for storage, for example. You have the ceiling, which you can have, it's very flexible. You can have it with different kind of production. So you got the extrusion one, that's 100% graphite based, so intumescent. Or you got the co-extrusion one. So you got one part is the intumescent material that builds the foam, and the other part is a normal used material for ceilings, like PE or PDM or something like that. Then you have a co-extrusion ceiling. We have some panels and some filler. For example, with these panels, you can build a partitioning between the cells. So, like as I told you with the fire protection foam already, you can build a partitioning between the cells. If one cell got in an event of fire, got a thermal runaway, you can protect the other cells from the cell, but you also can use it for lining in boxes, for example. We got some projects where we fill up some space in storage or transport boxes, fill up with these fire protection boards. And yeah, you can use it for the boxes when batteries are already got the thermal runaway and have to be storage or have to be transported from one point to another point. Then if more cells in the box react, the fire don't come out. So you protect the whole box, for example, with these panels. Also, we got some filler material for ceilings or stuff like that. It's now that's our main solution, I would say. It's our best solution, which we can use for every topic. And we got a lot of projects with this kind of solution, because as I already told you, the main focus is the lightweight. So we got a partner called Zartex. We developed a product together that's called Zartex Leo Coated. It's a composite material that we call it the next level of fire protection. We have the high impact protection. Later on, I show you some testing, what we are doing with our materials to test them, to evaluate them. We got a high impact protection like no material we haven't before. We can form in every kind of part you need. And the most important things, we got the weight savings. I can tell you, for example, many customers or many OEMs in the automotive sector wants to use aluminium because it's light, but the aluminium doesn't fulfill the fire protection requirements. Now that we got a standard from China, I don't know if you already know it. The standard for automotive from China is you have to protect the battery system for about 5 minutes. In these 5 minutes, no flames should come out of this of the battery, of the whole construction from the battery. So the aluminium got a melting point for about 500 degrees. If a cell react, we got temperatures from about 1200, 1300 degrees. So the aluminium are melting away. So the OEMs have to use steel because steel don't melt. But with this material of composite, we can build like a layer for the parts of the aluminium, and this kind of inlay protects the aluminium from melting. So the OEMs can build lighter with aluminium. For example, just the case of the battery system. If you use aluminium in comparison to steel, the steel is for about 25 kilograms heavier. So as you already know, when my car is heavier, I don't have the range, and the range of the electric cars is very important. So they have to build lighter, they want to build lighter, and with this solution we can achieve this goal. There. So here you can see some pictures. As I already told you, we have some some possibilities for this material. So we can build it in a monolithic structure. It's already only the fiber with the fire protection coating, and then some epoxy resin, and you got a small, for about 1 to 2.5 millimeters thick inlay that you can use. But it's already possible to build the whole battery box or the whole transportation case, or everything you want to build can you build with this kind of material. You can use it as a sandwich panel. You have of course you have more benefits like the acoustic bond. Because of the foam, you can use some cork inside it for the acoustic. You can change the core material. You have different kinds of structures that you can build up. And the most important thing, you have the fire protection. The fire protection is, as you can see on the picture above, the red layer is on the fabric and goes to the whole construction. So with this kind of material, we can withstand every test so far. And so for us, it's the best material right now because we can achieve all the fire protection goals, and more important, the whole impact of the cell when it reacts and goes to thermal runaway. Now it's, I guess, for you the most interesting part of this presentation, our research and development. We did a lot of research and development in our 4 R&D labors that we have in our company. Every product we produce by ourselves, so the research and development is real big in our company, and we do a lot of testing, and we gotta test the available by us that we use to check the materials, to prove the materials if they can withstand these high impacts. You can see it right now, what we have to do for these tests, but what are the requirements for these tests. As we know from our customers and from some self-knowledge, we have requirements for a test setup. If a cell goes through the thermal runaway, we got an explanation of about 20 seconds. 20 seconds is the range of time where the cell react. We got an instant temperature of 1400 degrees, so like a jet flame with particle bombardment. So there are all the particles that inside the battery comes out through a small hole like a jet flame and penetrate the substrate. So this was the requirements for our test setup. So we got in contact with some partners and built and built a really small but really effective test setup to use to check our materials, to check the materials if they can withstand this high requirements in the case of battery fire. So as you can see here, it's a test setup. You got here your inert mass, your propelling charge, that's all in the sleeve in the ignition unit. Then you have your substrate, and then you have a 2 millimeters or 2 centimeters, 20 millimeters, is the way from the end of the insert mass to the substrate. So we simulate a battery system where the cover of the battery is for about 20 millimeters above the cell. So, and then we let the cell react and go through the cover of the battery system, for example. But it don't have to be the cover of the battery system. It also can be a cabinet cover or something like that. But the test is really for us to show that our materials can withstand these requirements or even don't withstand. We also tested for about 50 or 60 materials, different kind of materials. I show you later on, and that's really impressive because it's a very, very simple and very very simple and very fast way to get a test set up. Now the customers from us don't have to go through a large-scale fire test with the whole battery system, sondern they can test the materials before by us, and if we pass our test, they can go to the large-scale fire test, and hopefully they will pass it. Here's a picture from this kind of test setup that's already patented by us. As you can see, here are the substrate. It's an aluminum plate, I guess, or a steel plate. You have the 20 millimeters from the substrate to the reaction material, and you can see it's very simple, but it's very effective. Here you can see some different material combinations that we have tested. So as you can see below on the left side, there are the test for just only a 2 mm aluminum plate, and the jet flame goes through for about 3 or 4 seconds, I guess. Then the jet flame comes out on the other side. We have tested this with some layer structure of our fabrics, of our coatings. We got the double layer ceramic fabric, as you can see the hole in the side, in the middle of the substrate, that protects the aluminum plate for about 6 or 7 seconds, and it's double layered ceramic. So as you can see, there are a lot of temperature, a lot of erosion. That's the really strong impact that the material has to be protected. And on the right side, you can see the material is Artex Leo coated, as I already told you. That's for about 3.5 millimeters, this plate, without aluminum, without any substrate, and the fire can't go through it, and they stop the impact for about 22 seconds. That's the time I already told you, which the battery reacts, and we can achieve this goal with this kind of material. And so that's the reason why we keep focus on this material in the area of battery safety, because we know it works. Here a little bit more about our test technology center. So as I told you, we got 4 production sites, and in these 4 production sites, we got 6 furnaces where we do the whole testing of materials for fire protection. But as I told you, the event of fire in a battery we can't do in this furnace, because that the furnace will break down. So we have to build up this test setup, as I told you, as I showed you before. But we got these furnaces to do some other orientated fire tests, made, for example, for cabinets or storage and transport boxes. You can use the furnace to check the construction of the sidewalls, for example, if you achieve your fire protection goal of 30, 60, or 90 minutes. We have a large-scale fire test with an opening up 3 to 3 meters, where you can install up to 350 measuring points. Yeah, for us, it's our customer service to do this development tests, as I told you. Also with our patented battery solution, it's all customer orientated. We get the samples from our customers, tested for them, and tell them, okay, you can pass the test, or you won't pass the test, or it's okay, it's not okay. Yeah, the why SVT, the last chart from my yeah, you got a wide range of high quality products. I just give you a small overview. I know that that's a lot of information about different kind of products. For us, it's quite difficult to put them in a line, because we have over 500 products in the group, and we can use all of them. And so that you got only a small selection of what we can do, and we will find the right solution for our customers. We got our own R&D and in-house testing, of course, as I told you. We got some standard solution, yeah, but the most thing we do in this kind of business is the tailored solution. So we got this tailored to your needs. You got a requirement, you ask us for help, and we will check based on your requirements, okay, what can we do for you and your project to achieve your fire protection goals? That's our main reason, yeah. We got our own documentation system, of course, and yeah, that's the normal things. But for you, you should know, and would you when you think about this presentation, we don't have this one solution. We have many solutions, and we got this tailor-made solution. So we go through your project, through your requirements, check, okay, what can we do for you maybe, and put on some different kind of solutions, then test them with you together, of course, to fix your fire protection problems. Yeah, that's the last chart from mine. Thank you really much for your attention. I'm a little bit ill, as you can hear, so I'm sorry for my speech. Hopefully you have a nice other presentations and a good talk to each other, and hopefully we can see or hear each other. If you got some problems, we will take care. We will help you wherever we can, and thank you very much.